This is problem 22.1 from Young and Friedman's University Physics book. They're giving us a flat sheet of paper and it's oriented so that the normal of the sheet is at an angle of 60 degrees to the uniform electric field. They're asking us to find the magnitude of the electric flux through the sheet. They're asking us, does the shape matter? And asking us to find the angle between the normal of the sheet and the electric field. When you find that angle, what angle is going to give us the largest magnetic flux and what angle is going to give us the smallest magnetic flux. Alright, so first we're going to draw a picture. We have our flat piece of paper with an area of 0.25 meters squared. And we want the normal of the sheet, that is the vector that is perpendicular to the surface of the sheet, to be at an angle of 60 degrees in a uniform electric field of magnitude 14 newtons per coulomb. So let's look at part A. Find the magnitude of the electric flux through the sheet. So what do we know? We know the area of the sheet, we know the magnitude of the electric field, and the angle between the electric field and the normal vector. All those variables are involved in the flux equation for uniform electric fields through a flat surface. It's equation 22.1 on page 729 in the textbook. Thus, we can plug in our variables and get a resulting magnitude of 0.75 newtons meters squared per coulomb. Part B asks us, does the answer in part A depend on the shape of the sheet? Why or why not? Looking at the equation, the only variables that change the magnitude of the flux are the electric field, the area of the surface in which the flux is being measured, and the angle at which the norm vector is oriented compared to the electric field. Thus, as long as the area remains continuous, the surface in which the flux is being measured can have any shape. Part C is asking for what angle phi between the normal to the sheet and the electric field is the magnitude of the flux through the sheet largest and which one's smallest. So we'll first do the first part. What angle is the largest? From trigonometry, we know that cosine phi oscillates between -1 and 1. Therefore, to make the flux the largest it can be, we want cosine phi to equal 1, or we want phi to equal 0. The picture would look something like this if the angle between the electric field and the norm vector is 0 degrees. Part 2 is asking what angle would give us the smallest flux. Again, we know from trigonometry cosine oscillates between -1 and 1. So in order to get the smallest value for the flux, we would set cosine equal to -1, or phi equals 90 degrees. The picture looks something like this with the angle between the electric field and norm at 90 degrees.